Conservator is a browser-based interface to a large database of videos. The interface lets you select frames from videos, annotate them, and add them to datasets. Within Conservator, the process begins by defining a project, specifying the domain for the datasets. For example, the ADAS project gathers images for advanced driver assistance. Conservator allows you to upload videos and images into a project or into folders within it. Conservator recognizes a variety of video formats, including MP4 and WMV, infrared formats such as SEQ, and image formats such as JPEG and TIFF. Conservator stores and displays videos and images in both thermal and visible formats. There's a search capability that helps you to find videos that contain objects of interest within this project or elsewhere. You can add tags to videos to make them easy to find. Conservator assists you in finding videos in another way, by running existing neural network engines in the background. These engines identify a wide variety of objects. Such identifications are called predictions. As a result, you don't need to rely entirely on your own videos to find objects of interest. You can search across Conservator's large space of videos to find examples of many objects, such as cat or suitcase. Conservator's powerful search language allows you to specify complex search criteria. Here, we search for videos uploaded by me with a thermal spectrum in the last month that contain a prediction of a person. Once videos are chosen to contribute frames to a dataset, you may select individual frames from the video. You may also select consecutive frames or every nth frame. A sequence of frames is called a segment. Within a dataset, images must be annotated. That is, certain objects must be boxed and labeled. You can perform annotations directly within Conservator. Conservator can speed up the annotation process by letting you accept some existing machine predictions rather than creating human annotations from scratch. Finally, annotated frames are approved or rejected by the QA team. In a properly completed dataset, all frames have QA approval. The final result is a dataset with a well-chosen set of frames, each properly annotated. By the way, the process of selecting images for a dataset is called curation. The dataset is now ready to be used for its intended purpose, either to train a neural network or to verify that an already trained neural network is effective. Throughout the process of creating the dataset, interim versions can be committed to the version control system. Conservator's underlying version control system provides the benefits of source code control, such as facilitating snapshots, providing a history of changes, and offering the ability to revert to an older version. The repository of datasets is accessible to users outside of Conservator. These users can check out a dataset, manipulate it, and check it back into the repository. Typical offline manipulations include adding or deleting frames and editing accompanying annotations and metadata. FLIR supports such offline manipulations via a package of scripts in an application programming interface. Offline work can also include bulk operations or operations performed by third-party tools. Conservator can produce a statistical summary of a dataset. This document, called a datasheet, describes the comprehensiveness of the dataset, going into detail for each type of annotated object. For example, for all cars annotated in the dataset, the datasheet will show their distributions by size, sharpness, contrast, and brightness. Here's a histogram showing the number of objects of each type grouped by size. To sum up, FLIR Conservator provides a comprehensive database, infrastructure, and toolset that allows teams to create image datasets. Image datasets are the source code required to train and test neural networks, the engine of today's intelligent vision devices.